Now let's move on to the differential elements in the Cartesian coordinate system. So here we know that the x, y, z is the Cartesian coordinate system, and in the differential element we have to convert it in a del x, del y, or del z. Differential element system means we are taking a very small quantity that is called del, and with a point P we are just changing the direction or the location of the point P, which is making a small cube which is going to be like this. Let us take, this is the z axis, this is the z axis, this is the y axis, and this is the x axis, and we are making, assuming a small cube which is going to be like this. This is the small cube we are assuming, and if I consider a point P which is at the location of this vertex, this is the point P, and if I moving from this point to this point, that means we are giving a small displacement of x, y, and z, making a point P dash. So we can assume that P having the coordinates of x, y, and z, and the P dash which we are obtaining from the small displacement that is called del, having the coordinate of x plus del x, it should be y plus del y, and it should be z plus del z. So that means this small displacement is del y, that is called a small displacement del y. This small displacement we are calling as a del z, and similarly that we are calling as a del x. Del x in the direction of x, del z in the direction of z, and del y in the direction of y. If I if we want to find the distance between P and P dash vector, then how we can go? Like this fashion we can do this. Let us take, this is the small point O, and here the OP distance, here the OP dash distance. If I just write the equation for the OP dash, so we can say that we are already done. It should be x, ax cap plus y, ay cap plus z. It should be a z cap, and the distance from OP dash vector should be equals to x plus del x. It should be ax cap plus y plus del y, ay cap plus z plus del z, it should be a z. And if we want to define the distance from P to P dash, then it can be calculated like this fashion. P dash should be equals to OP dash vector minus OP vector. So we can write, it should be P dash vector should be equals to, OP is nothing but the difference between these two vectors that we are obtaining is called, it is called x. I think it is a x cap plus it should be del y, a y cap, it should be del z, it should be a z cap. So this is the differential length that we are obtaining here in the system, which is called in the Cartesian system. We are having differential elements like this. So in the differential elements, basically we have to deal with the differential line, which is called differential line. So secondly, we have to deal with the differential surface, and third thing we are dealing with the differential volume. This, the term differential basically useful in order to find the intensity of electric field or any force or any charge that we are discussing in uh, the chapter number 2. What is the significance of this? Why we are doing this? Basically, we are just assuming a small displacement from the any sphere or any charge line or any kind of the conductor, and just by making an analysis like this. So differential length, we can say differential length vector, differential length we can say it is going to be like this. It is a differential length which is nothing but del x dx cap plus del y dy cap, it should be del z dz cap. So this result keep in mind, because we are to use this numerical in this in the numericals. Okay, next we can move toward the differential volume. Differential volume. So dV should be equals to del x, it should be del y, it should be del z. This is the formula for the differential volume. Okay. Now let's move on to the third important part that we are going to discuss, which is very important, which is very important, because if we understand this concept, then we can easily solve all the numericals that we are going to discuss in the coming classes. That is called differential volume. It is very important. It's called differential surface. General formula to represent any differential surface. General formula. General formula is very simple. It is like this. ds surface vector. Vector is having a magnitude, so it's having a magnitude like this, and it's having a unit vector which is normal to the surface. So this is basically nothing but a unit vector, or we can say that this is the unit vector, or the area vector. So firstly, we have to understand what is the significance of the area vector. Area vector is a vector which is always making an angle of 90 degree with respect to the surface. Let us suppose if this is the surface like this fashion. So the area vector of this surface is basically the 90 degree to the surface. So similarly, if the surface is going to be like this, so the area vector of the surface is basically upward direction, which is 90 degree. It may be towards y, or maybe what it may be a minus y. Similarly, it may be above z or maybe minus z. But the area vector is always perpendicular to the surface. So keep this concept in the mind that the area vector of any closed surface, of any surface, is having a direction which is normal and is the normal to the surface. If I consider the sphere or the cylinder like this, the cylinder is there. The area vector of cylinder is nothing but this is the which is normal to the surface, because surface is curved, so the area vector is making an angle of 90 degree to the surface. The area vector is nothing but the vector which is along the direction of the increasing, plus it should be normal to surface. That means it has to making an angle of 90 degree with respect to the surface. That we have to keep in mind. So the area vector we have to keep in mind. For this concept that we are going to use in this coordinate system. So we have seen that the cube is having the 6 faces. So let us draw the cube again. If I just draw the cube again, it is going to be like this. This is the cube. Okay, here we can say that this is nothing but the z. This is, we can say that this is the y, this is z, and here we can say this is the x. And the area vector of z is nothing but it should be a z cap. For ay it is basically ay cap. For ax it is basically a x cap. We know that because we have done already. If we want to define the area vector of this cube, then how we can proceed? We can assume there are 6 surfaces. This is the surface 1, that is called the front surface. Similarly, there is a surface which is called the back surface. Okay. Similarly, there is a surface which is nothing but the left and the right. The surface which is the left, surface which is right, surface top and the bottom, and front and the back. For each and individual surface, there should be area vector. For this surface, which is towards the right, the area vector basically, which is making an angle of 90 degree, so it should be like this, in the direction of the ay cap. Okay. The area vector for the back side, it should be like this. It should be minus ay cap. If we are thinking about the top direction, the area vector is basically, it should be normal to the component, to make a 90 degree angle. It should be a z cap for the top, and for the bottom we can say it should be minus a z cap. Similarly, for the area vector for the front surface, so the front surface having an area vector of, in the direction of the ax, which should be a ax cap, and for the back surface we can say it should be minus ax cap. So this is the significance of the area vector, and with the help of this concept we can define the differential surface. So if we defining the differential surface for the dsy vector should be equals to in the direction of the ay vector. So here the dy is nothing but it should be, this is called dx, and here we can say this is dz. So dx multiplied by d del x multiplied by del z in the direction of the y, it is called the area vector for this y component. This is del x, or we can say dx dz. Okay, you are taking a del or d is basically it's the same. You just I'm sorry, we have to use the d, it's a dx dz, and it is basically dy component. Okay, if I just want to write the dx vector, so here the x component is there, which is moving like this, and if we have to write the equation for the area component, this is dy or dj. This is dy, this is dj. Similarly, we can write the dsz vector should be equal to in direction of az, because magnitude and direction, this is magnitude having the, this is dy and this is dx, so it should be dy dx. So this is basically nothing but the area vector direction for the, or the area vector equations for the Cartesian coordinate system. So I think you will understand the differential element in the Cartesian coordinate system, how we can define the equations just making a vector which is normal to the plane surface, making an angle 90 degree with respect to the plane. This is the concept regarding the Cartesian coordinate system. Thank you.